This episode is sponsored by AXIOM Cloud. Refrigeration should make you money. Get paid by your utility, save on your energy and maintenance, and fix problems before they alarm with AXIOM Cloud's apps. For information, please go to www.axiomcloud.ai. Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode.
Hi, guys. Welcome to the Advanced Refrigeration Podcast. I'm your host, Kevin Compass. I'd like to take a minute to talk about one of our sponsors, Parker Sporlan, and thermostatic expansion valves. How can you guys always have the right thermostatic expansion valve for the right application without having to carry hundreds of valves in your truck? Well, that's simple. Using Sporlan's interchangeable cartridge-style valves. The Q valve for conventional and the BQ valve for balance port. It's as easy as 1, 2, 3. It serves thousands of unique applications. So 1, you just select the thermostatic element for your application. 2, you select the body style you need. 3, you select the right size cartridge for the application. These easy to select and assemble valves mean you always have the right valve for the job on your truck. For more information on the Q and BQ valves, visit sporlan.com. Thanks, guys. Enjoy the episode.
Good evening, everybody. Welcome to Advanced Refrigeration. We're here with your host, Brett Wetzel, Kevin Compass, and we have a special guest from AXIOM Cloud. Amrit, how you doing today, sir?
Doing well. Hey, thanks for having me.
Absolutely. Oh my God, brain fart. Kevin, what are you doing to this week? Kevin looks rested and well, and doesn't look like he's been through a pile of doo-doo. So what's going on with you this week, man?
Oh, I had a nice, easy week. I was only out of town one day, so I've just been, cleaning up little construction jobs here or there before we get kicked out for the holiday.
Milking it.
Yeah. I say that, and then I've been doing some EMS quotes. So yeah, I've had an easy week so far.
Yeah.
Nothing's burned, nothing's caught on fire, and so far, it's always Friday.
You guys been working on turkey trucks at all?
Yeah. No turkey trucks.
No, I'm a girl now. Like I shouldn't say that. I don't. My hands are clean now. This week was the first week I think I picked up some tools in a minute. I was training in California 2 weeks ago, and now this week we're down in the Houston Center setting up some RDM stuff. Working with TJ Coggins, helping me figure out programming for RDM. But we're here to talk about you tonight, man. Tell me a little bit about yourself, how you started the company, about your company.
Yeah, absolutely. Yeah, my name's Amrit. I'm the CEO and co-founder of AXIOM Cloud. So we're a California-based company. We're a startup. We're a software company. We've been around for like 18 months at this point. Our team is 16 people now, so pretty early stage. But yeah, essentially what we're doing is we're bringing cloud analytics to grocery refrigeration. And so, I can tell you a little bit about why we started the company if you're interested.
Absolutely.
I'll say this right off the bat, and I hope I don't ruffle any feathers, but I'm a climate change guy. That's why I'm in this space.
Oh, podcast is enter. If that's it, we're done. No, I'm just kidding.
Get out of here. No, but I mean, I've always wanted to work on climate change. Basically, that's what I'm kind of dedicating my whole career to. And so, this company is really exciting to me. The reason we started it is because obviously grocery is using an enormous amount of energy, and so much of that energy goes into refrigeration, over half. And then on top of that, another major contributor to greenhouse gases is refrigerant leaks. So grocery sits right in the middle of those two things. It's, you can basically make a huge impact on both of those sectors, energy and refrigerant leaks, if you're working on grocery and if you're working on refrigeration. So that's ultimately why we started this company, and why I got into this space in the first place. People used to look at me a little funny when I told them I work in grocery refrigeration. But ultimately, it's an incredibly huge opportunity, and people are just overlooking it all the time. It just, nobody thinks about this. It seems like, we're all working on this thing that, has so much opportunity, but a lot of people don't think about it. It's very unsexy is the word I hear used a lot.
Oh yeah. My mother-in-law and father-in-law both think that I work on refrigerators. And when I first met them, they were a doctor, lawyer, personal assistant. I'm like, I'm a climate control engineer.
Yep.
Making it try to sound semi-important of what I do.
Yep. I work on refrigeration. So yeah, I mean, what we want to do is we want to kind of help this industry do what almost every other industry is already doing, and that's use data. Honestly, the most basic thing that we do might be the most valuable, and that is get the data out of those refrigeration systems in grocery stores, kind of liberate it from the control system and send it to the cloud. That in and of itself is already, something that's not done in a lot of cases. I'm sure you guys run into that all the time. You can't get data out of certain controllers because, maybe they don't have any internet at all, or they're using a dial-up connection or something like that. Or if you do want to get the data out, you have to go into each unit or each refrigeration controller one at a time at a specific store or at a specific location. You can never have that enterprise view of all the controllers and all the stores at once. So, that's already being done in so many other industries, and we want to apply that same playbook here, and so that we can get those same benefits. Use data to transform how we're powering these systems, how we're maintaining them, how we're operating them, in huge ways, reduce refrigerant leaks, et cetera.
So if I'm correct, you guys use algorithms in order to figure this out, or something else to figure out, the energy consumption?
Yeah, great question. So I mean, we call it a digital twin model. So, I think GE coined that term maybe a long time ago, but the whole idea is have a digital replica of the refrigeration systems in a grocery store operating simultaneously in the cloud. And so we're using, rules, physics-based rules, thermodynamics-based rules, modeling to enable that to happen. And then we're also pulling all the data out of the existing controller, whether it's an E2 or a microthermo or whatever else. And we're feeding all that data into machine learning algorithms. So, machine learning algorithms, or ML algorithms, basically, they're able to just ingest massive amounts of data and make sense of it and draw conclusions or insights from it. And so we're using both those techniques, the thermodynamics rules and the machine learning, simultaneously to create this digital twin model. So with that model, go ahead.
No, I'm sorry. So you basically have a cartoon would be really campy, but like basically you have a simulation of a rack with what compressors do what horsepower, what circuits are doing what BTU consumption, to assume what the total energy consumption should be of that rack. And if it's not working properly, I'm assuming that's when you all step in and say, hey, you have a problem because you're using X amount of consumption or whatever have you, correct?
Pretty much, yeah. So I mean, if you're looking at a specific like medium temperature rack, let's say at a grocery store, then the digital twin's gonna, like you said, it's gonna have all the compressors, all the horsepowers, and then it's gonna be able to say basically, look, this is what the pressures and temperatures should be. This is what the power consumption should be at this moment for this rack, because we know over the past 4 weeks or whatever, this is what it's been with similar outdoor air temperatures, with the float is maxed out right now on the suction side. This certain case group is in defrost. The condenser split is running. The heat reclaim is off right now. And so it's looking at all those different factors and the trends every time and basically saying, this is what should be happening. So this is what every pressure, every temperature, every valve position, every compressor status, every condenser fan status should be doing right now, according to all these conditions, or something close to this.
Now, sorry, go ahead.
Yeah, go for it.
So with this whole thing, are you guys installing KW monitoring at the same time you guys are doing this to get more of that data, or are you guys doing this without KW monitoring and just monitoring parameters in the controller and inputs in the controller to see what it's seeing?
It really depends. So, with certain customers, for a lot of grocery stores, we actually don't add any hardware at all to the store. So we'll connect to their existing E2s or their existing microthermal controllers, basically via VPN. And so the idea is, connect to those controllers, and then we can take all the data out of them in real time, and we can also send override commands back into them in real time. And then we're taking all that data from the controller, we're combining it with weather predictions, with grid signals, with utility tariffs, things like that, all kinds of different data streams as well to help build that digital model. In some cases, our customers will ask us, hey, we want more accuracy in these certain areas, or we want to basically use this refrigeration system like a battery. We have this app called Virtual Battery. But the whole idea being, basically, in those cases, we will add power meters in the store. So those are optional. Short version.
You utilize the existing EMS in order to accomplish this? Or do you have your own separate power monitors?
So, if we're going to add power monitor, the optional power meters, which are, we definitely don't do in every store, then those will, a lot of times they'll plug right into the existing controller so that, even if that customer decides to stop subscribing to our app at some point, they're still getting the value of having those meters on site.
Yeah, only reason why I ask, because there's some customers out there that are very conscientious. Whole Foods is a prime example. They put power monitors on everything, on their defrost panels, rack, and they have it hooked up. They utilize Parasense, and basically, they get that system and get that information fed, and then they can see what it was. But the hardest thing I find about a lot of predicting this stuff, and I do truly believe in algorithms, but how do you know, if you walk into a customer, how do you get a baseline? How do you get a baseline knowing that right now the rack is running what it's running right now, but who's to say that, it's just running really bad right now? And
most of them are.
Yeah, exactly. So how do you find that baseline? How do you convince the customer to, this is how you're running currently, but with the predictions that our AI can do, basically, you could probably get a lot more, energy savings if we were to do X. Can you explain that? I'm curious, and I'm sure so is everybody else.
Yeah, totally. So a really big part of it is kind of the rules-based elements of the model. So, we know what these systems should be doing according to, if they were operating according to their manufacturer specs. This is exactly what should be happening right now in this moment in time with all these different operating conditions. And so then we can look at what's actually happening in that building or in that particular system and say, hey, this is way off. This is like 40, 50% off. And so that's how we're able to identify there's a problem. And that might be, in terms of, compressor runtimes. It might be in terms of power, if we have those power meters. It might be in terms of COP, comparing the actual rack coefficient of performance to the ideal COP. So identifying those sorts of deviations can yield huge insights. They can also help us with maintenance insights. A big part of what we do is predictive maintenance as well. And that's a huge advantage of data analytics, whether it's from us or anyone else.
So do your algorithms and AI take in effect, usually when I'm diagnosing something, I'll dig into the Copeland, which used to be the Copeland curve charts, right? Now they have the Copeland app where it basically tells you if you're running this. What's that?
I spent a lot of time in those.
Okay.
Copeland online portal. Oh my goodness.
I was just curious, like how you implement those in your predictions.
Yeah. I mean, what's really interesting about those, one of the early analyses we did is we must have downloaded hundreds of those from Copeland. And then we also went to Bitzer. We also went to, the IR used to have their own branded one compressors, and then the Carlisle. And so we downloaded so many of these data sheets. And then we we took all the data off those, and we took all those curves, which are like 4 or 5 dimensional curves, and we stuck them all into the same set of axes and into the same analysis, basically. And we looked at it. It's all the exact same curve. And so the crazy thing is that it's all just basically, if you look at EER versus lift being, saturated condensing temperature minus saturated suction temperature. Maybe it's 50, 60, 70, 80, 100 degrees, whatever. The difference between the high side and the low side. Mm-hmm. If you compare that to the EER or the COP, basically the energy efficiency of that system, it is just a perfect relationship, no matter who the manufacturer is, no matter what size the compressor is, et cetera. And so, that's one of the core insights is like, this is not rocket science. All we need to do is compare against this one curve. And that's honestly a big part of the baseline for the compressor element of our digital twin model. And then we have other elements for the condenser, for each types of display cases and walk-ins and evaporators and things like that.
Now, are you guys able to do predictive maintenance? They'll say, we have some customers that have CTs on every compressor, and they're actually looking at amp draw on every compressor. Are you guys able to do predictive maintenance with that compressor using that curve chart to say, okay, this set of conditions, we're running this suction, this discharge. We have this amp draw A. It should be, say it's 10 amps. It should be 14 amps. We could have a possible compressor problem. Or are you guys able to do predictive maintenance to that point with compressor analyzing?
Oh yeah, absolutely. I mean, if you have that amount of data with if you have CTs on all the different legs for each compressor. So if you have 3 CTs per compressor, my gosh, what a wealth of data. I don't think you have many. There aren't many grocery stores that we've come across that have that amount of metering. But if we have that, then that's something that we can basically feed into the model and feed into the machine learning algorithms, and look at things like how does this compare to what the compressor should be doing? How do the three phases compare to each other? Are they out of balance or not? And then you can't just look at the curve off the manufacturer data sheet. You have to also kind of adjust for things like what is the actual discharge temperature right now, which is not going to be exactly perfect 20 degrees or whatever it is above the where it should be essentially. So yeah, doing those sorts of comparisons, and then also looking at trends over time. And so I think this is a really powerful element. So if you're saying, hey, this leg of this compressor is a little bit out of whack, but it's been out of whack like that for the last 3 months, that's not a big deal. But if we're looking at over the last week, it was right exactly in line with the other 2 phases, but now it started to get out of whack really slowly over the course of 2 weeks, and it's getting worse every time. That's a big problem. And that there's a failure around the corner on that. So, I mean, one thing that I like to say a lot, which I really think is true, is that the stuff that we're doing is not rocket science. Like, honestly, everything that I've said to you guys today, like if you guys looked at the data streams in UltraSight or whatever else, in MT Alliance, you would be able to easily see this stuff too. The problem is that nobody can afford really smart techs. First of all, there aren't enough really smart techs. And second of all, no one can afford having a set of eyes on every single system at every grocery store all the time. It just doesn't make any sense. It's not a good job for humans to do. And so, that's where computers come in, is the ability to have eyes on everything all the time. So yeah, it's really not rocket science.
No, I mean, it's the equivalent of, like Kevin going in and basically looking through all the graphs and then finding a week's worth of work of things that have went wrong, right?
Yeah, you said it. And ideally also looking at all those graphs and saying, we're not in the red zone yet. We haven't caused a threshold alarm, but I'm seeing something that is going in a worrisome direction. And if I don't do anything, this is what's going to happen. And so therefore, these are the steps I need to take to correct it before it turns into an emergency midnight work order where I'm replacing a compressor.
Do you monitor pull down times as well? Like, is that
absolutely.
part of the? So I keep bouncing back. Is it definitely AI or is it algorithm?
So yeah, it's a great question. The short version is that it's technically AI, but I wouldn't say it's like groundbreaking AI. It's not like, better than Tesla or something like that. Not even close. The stuff we're doing is honestly, it's pretty darn simple in a lot of cases. We are adding more and more of that advanced functionality though, where we're using the latest and greatest and really cutting edge AI. But a huge amount of the value we provide is simply in the data analytics and in the applying this digital twin model that uses a lot of machine learning and a little bit of AI. And then some of the more advanced AI is some of that has been deployed already, and some of that is still coming. It's in the pipeline.
So obviously, you still have like people. You said you have 16 employees at this point in time. Yeah.
Yep.
So those employees, are they going over? So I guess explain to me like how this actually works. So you do a test with a customer. Basically get all I'm assuming you're getting all the information of models and serial numbers of the racks, the compressors, the condensers, so you can, and BTUs, refrigeration schedules, so you can, type that all into an algorithm, or, and then
all that stuff we're able to pull right out of the config files, which are in the controllers. So we do a lot of auto configuration, so we don't have to spend, days of manual entry. That would be brutal.
Okay. No, because computers are only as good as the data that you're putting in, right? Like I tell my guys all the time, you give me shit information, you get a shit diagnostic, right? So, same thing. If you're not getting the correct data, and computers are as fallible as the people entering the data. So if you're pulling information back, I understand both sides, but like I'm thinking about, if you're pulling that data back, like I'd be more comfortable with like, going through the refrigeration schedule and putting what's actually true blue that was supposed to be designed.
Yeah, but when's the last time you walked into a store and it actually matched the refrigeration schedule?
Never.
Maybe a week ago.
Maybe. Okay. Well, you've been at better stores than we have, Brett.
No.
But no, I totally understand what you're saying. And so basically we agree that's a huge problem. The best information that we have available to us, unless we physically go on site and look at every serial number of every single valve in the whole store, is basically understanding what's coming out of that controller. Because at least that controller is approximating what's on site well enough to run things without causing alarms, right?
Yeah.
And so, from there, basically, how when you go to Google and you type in something and you misspell it, you generally still get what you're looking for. And so they have all kinds of techniques basically to kind of use, fuzzy logic or different forms of data validation or data correction to figure out what you meant. So we're kind of taking a similar approach here where we're looking at these various data streams, and, if a tech, one of the biggest issues that we have is honestly data cleaning and essentially mapping the correct types of data streams to the right labels. So, for example, if a tech misspells sensor when they're programming an E2, it's like, a computer can't read that. And so we have to enable the computer to kind of be flexible. And so there's all kinds of ways to do that. And so we're using a lot of those techniques, basically be flexible with stuff like that. On top of that, if we're receiving data streams, we're actually not just blindly receiving those data streams and assuming that they're perfect and they're the word of God. Instead, we're looking at those data streams and we're constantly asking the question, does this data stream make sense? So if this is a low temperature, discharge air sensor, and we're getting a value of 86 degrees Fahrenheit, that doesn't make any sense. And so therefore there's something wrong. And so we're constantly using that type of data validation algorithms to basically determine, is the data we're getting good or not? And so, I just gave you the simplest example ever there, but
so something like, is the product, like if the product temperature sensor colder than the discharge air, right? It should be a physical improbability, right? But
exactly,
if the sensor is swapped, or if the sensor is going bad, or someone has put an offset in it,
the offset. Oh yeah, we've seen that. So that's getting one layer deeper. So like, is this data stream always higher? Like, is the drop leg always lower than the discharge? And if it's not, something's mixed up.
On a blended refrigerant, yes. Always,
Oh, fair.
because well, how many stores you've dealt with that have been under remodel, and they change out the cases, they change out the refrigerant, but then they never change out the sizes of the liquid headers, and then basically you get this mix of where the head pressure is either the same or even sometimes lower, because technicians sometimes mess up where they've set everything for suction dew point their whole life. Well, now with these large glided refrigerants of 12-10 degrees, if you set something to a 40 degree saturated on dew point, you're probably getting 30 degrees on your liquid side or your bubble point. So basically
That's true. That's
35.
true.
So then what do your EPRs do? They slam down, and then basically you have a compressor that doesn't have to pump as much, and so you don't have as much load, you don't have as much head, and then you start stacking all your refrigerant in your condenser, and where does it go?
Right in the suction header, I guess.
Oh, it just gets stacked in the condenser, and then basically
Okay.
you have intermittent flow because you basically don't have enough head pressure to push that refrigerant out.
Okay, you're getting over my head. I'm not going to lie, Brad.
Sorry. I'm muting for the rest of the time.
No, but yeah. So there you go. So that kind of thing might flag our, we might flag that as an error on our data, and so then humans would have to go in and take a look at that and say, wait a second, something really screwy with this store. They clearly retrofit it with 448, even though the R schedule says R22 or something like that. So then, at that point, then humans have to get involved, and there's manual work that goes into it. But a lot of times, software can take care of it.
Now, do you send any of your own people out to the sites, or do you tell the customer what's going on and what has to be investigated, or how does that work?
Yeah, good question. So, I mean, with the virtual tech, so we have two apps. One's Virtual Technician, that's the predictive maintenance one, and also continuous energy commissioning. So the whole idea there is, basically catch problems before they turn into a big outage, and then, send either fix the problem using software. So a lot of times, this problem might be, hey, somebody left a walk-in door open overnight, and the coil's all iced up, and so rather than paying a tech $250 for a truck roll and $125 an hour once they get there to watch a defrost for 2 hours, let's just initiate that defrost remotely. So easy, so simple.
Now, who would be doing that? Would the AI be doing that, or would somebody from AXIOM have to initiate that defrost?
So it depends on the customer. In certain cases, the customers are saying, yeah, go ahead and automate this stuff. Kind of like the controllers making all kinds of decisions every minute. In this case, we would temporarily override that controller to run the extra defrost. In other cases, the customers basically they'll have like some sort of commissioning agent or a contractor. Like we work with CoolSys on various accounts, and so then we'll flag it to CoolSys and they'll do it remotely through Ultrasite or whatnot. So, I mean, that's a lot of that's at least a portion of the problems we find can be fixed that way, remotely or via software. There's other types of problems where you have to have someone get out there on site. And so for those, we'll put together what we call an anomaly, which is essentially just a draft work order. But the work order is way more than saying, hey, you get a case temperature alarm on this particular lineup. Instead, that draft work order will say, here's the exact display case where you're having that issue. And then, sorry about that. And then beyond that, here's what we think the root cause of it is. So that might be, maybe we've noticed this trend happening over a period of time. And so, we think that it has to do with a liquid line restriction. Or maybe it's, somebody just went in and recommissioned the thermal expansion valve or turned on the float back at the rack. And so, we'll identify what exactly we think the root cause is. And then we'll tell a tech how to fix it step by step. And so the whole idea here is, first of all, and a big part of this is batching and triaging too. So first of all, don't get the tech out, decide if they don't need to be there. If they are going to be there, then enable them to be there a really short amount of time. They don't have to, go all over the place to try to figure out where the problem is and what it is and how to fix it. And also make sure they're going to succeed more frequently. So even if it's a junior tech and I'm sure that you guys are hearing this all the time, that there's so many folks coming straight out of school who don't have experience, and there's just such a shortage of techs that they're being handed really challenging problems right off the bat, which is not good for anyone. So help them to succeed more frequently, even though they don't necessarily have as much experience. And then after that, because they're already on site, the customer already paid for that truck roll. What are one or two other little things that can be done in that store in another 30 minutes or 60 minutes that will avoid future truck rolls, because they're kind of like, festering problems in the background that are going to very likely lead to other truck rolls in the future.
So 2 questions before I forget, because I'll see a squirrel and then that's it. One, do you guys monitor HVAC and do predictive maintenance on that? And the other question is, which would probably help with a lot of the refrigeration issues, basically monitor pressurization in the building. Because I'm sure Kevin and I could probably spit out 100 different times where there's nothing really wrong with the refrigeration. It's more the environmental. All these cases are what it's referred to as type 1 cases, where it has to be 75 degrees, 55% relative humidity. And if any of those 2 factors are bupkis, then forget it. Then it's going to cause that. Yeah.
I hear you. So short answer is, right now we're monitoring everything connected to the controller. So if the E2's on if the HVAC's on the E2, yes, we're getting all that data. Unfortunately, we're not doing much with that data right now besides displaying it. So, it goes to show that we're still early stage. That's definitely something that we're building out in the future, because just like you said, you can't look at the refrigeration in isolation. You have to look at the HVAC too. If there's enormous amount of humidity in the store and everything, all the cases are sweating and they're filling up with water and the coils are icing up. Doesn't matter, how good the suction float is, or something like that.
And you'll see that in the analytics too, right? I mean, you'll see the float just be non-existent. It'll be running rack suction pressure all the time. Kevin, what was it? Probably about 3 months ago, you were having a problem with the store intermittently, right? And it was all because pressurization, right?
Yeah, it was every day. Every day at 9 a.m. when the exhaust fans kicked on for the deli and the front of the store would go from a 48% relative humidity to 80 to 90%.
Oh my goodness!
Makeup
so immediately, and then the defrosts are all reaching their, they're terminating at the end of their longest window, stuff like that.
We weren't even getting to that. It was a glycol rack, and we were actually overloading the glycol side of the rack. Like it maxed out the glycol capacity, and you could watch the glycol trend up, with the humidity. As the indoor humidity went up, the glycol trended right with it, because all these cases were just absorbing so much heat and so much moisture from the air. They were just, pulling all that latent load out, and it increased the load so much that it actually, you could watch the KW on the racks just spike up every day. Wow. KW and the suction pressure, and you could watch the glycol load just go through the roof every single day. And this is something that all that needed to get done, they had no makeup air. So they had 11 exhaust fans and no makeup air. And all they needed to get done was open some rooftop economizers. I mean, this customer would have saved, thousands of dollars. I mean, it was one of those things we couldn't really convince them to do it, but we installed a piece of equipment, and every day it was going down because, it was an open air dairy cooler, and it was frosting up daily. They ended up putting like 12 defrosts a day in it to make it work. And that's just, that's what it took and as soon as the humidity problem went away, thing works great. As soon as the humidity, I'm in Chicagoland, so as soon as the humidity went away, all the problems are gone. Then you could trend it back. This is actually, microthermal, so I was able to trend it back for like 3 years. This has been going on. 3 years the store has been dealing with this, and it's a pressurization problem.
You would think that people walk into that and they notice, that's weird, all the doors are open. And then their ears start popping when they go inside.
Well, this particular store leaves the dock doors open.
Okay. 3
large roll-up doors. And
I bet it's windy back there.
It is. I was literally, I don't know if I still have the video. I was literally taking a lighter to the dock door, and it would fold the lighter over.
Wow.
That's how bad the building was in a negative.
I had something similar where it was a light industrial account where basically we couldn't figure out every day. Like it would just the coolers would go to shit, the temperatures would go to shit, and basically it was because they would turn on the smoke removal fans for this big facility. Well, it would put such a vacuum on it, like where the trucks actually back up to the bumpers. It was actually sucking the bumper away from the truck and actually putting that much of a because the humidity and temperature. I mean, it was supposed to be 3 defrosts a day, electric defrost. We've had to turn it off and make it off time. And basically, we would float. What I ended up doing is floating the suction pressure all year round until it gets about 75. Because at that point, then that's when they turn on the exhaust fans, and that's when everything goes not good.
Yeah, building pressurization is probably one of the most overlooked problems that there is in a grocery store. To be honest with you, I see more stores with building pressure problems than anything else. And then building pressure problems lead to every other problem.
Makes total sense.
That's the only reason why I brought it up. Sorry to get off the soapbox.
No, that makes so much sense. Do you guys in those types of stores, are you seeing the rooftop units connected back to the refrigeration controller, or is that typically totally separate, standalone?
Usually they're on their own controller, like their own. It depends on the customer. Some of them have them on the EMS controller, the same as the refrigeration. Some of them have them on a third-party controller, completely different, and some don't have any control whatsoever. But I mean, convincing a customer, which I've been doing a lot of work for a certain customer lately, they've been putting in a building pressurization sensor in the center of the store to run the dampers on there, and I mean, it's working great. They're putting in dehumidification on every rooftop, but at the same time, like they're able to control the building pressure, and it's probably saving them a ton of money. I mean, being able to control that building pressure and keep it at a positive saves a tremendous amount of money.
That's by opening up those economizers or putting another rooftop dehumidifier.
Yeah, I mean, just being able to to be honest, if I'm doing some commissioning and we do some independents out here, and I do a lot of retro commissioning and stuff, I will put a building pressurization sensor in. So, I mean, I could look at it on a controller, on a refrigeration controller. It may not be doing anything, but at least, in the middle of summer, I could see, okay, this building's got a negative in it. This is a problem. So instead of, dealing with these humidity problems, we're going to fix the negative building problem first before we start messing with defrost and everything else.
Totally. Yeah. I mean, I guess I'll have to check with my team on this, but I do think that we're getting, temperature and relative humidity from various spots on the sales floor. Usually, I don't know if we're getting pressure through the refrigeration controller a lot of times. What I do think though,
don't use it. I mean, I very rarely see somebody put it in, but I mean, bang for your buck. That's a lot of bang for your buck for, you're talking a couple $100 sensor, make all the world of difference with analytics, being able to see that.
Yeah, no, that makes sense. I mean, if you have the temperature and relative humidity, that's really the most important thing though, right? So even if your pressure is terrible, if your humidity is not too bad, then you're not in terrible shape. Yeah,
I mean, as long as the humidity isn't bad, where Brett lives, he lives in hell basically. It's humid all year round. So
are you in Georgia or something?
No, I'm in Dallas, which the humidity isn't that bad unless you go down.
Terrible.
No, it's not. Compared to blisterly Chicago. I mean, hey, listen, it was cold this morning. It was 61 this morning. So
I hate you. It's 18 this morning.
Oh man.
That was the only reason why I brought up the pressurization, because I mean it is vital, and a lot of times I tell technicians, like, if they're having an air conditioning problem or multiple case defrost issues, check the pressurization before you do anything, because usually if it's multiple cases, like I always look for commonality in problems, right? So if you have multiple cases icing up, it's a either a common problem to the rack or common problem to basically the to the building. So like I said, that's one of the first things that I have them check.
I mean, you said it there. Where the rubber meets the road is where you're getting these problems on the refrigeration side, right? So it's like if you're noticing that suddenly, like for example, this is the example where data can be so powerful. Even if you don't have that sensor necessarily, I don't think that we're doing this right now to be totally transparent. But one thing that could be done with the data that we're getting is essentially if we're noticing trends like, man, this is so weird. All the EPRs are maxed out, and they have been all day. And they start getting maxed out at 9 a.m. and not until 4 p.m. every single day, and that wasn't the case over the last 2 weeks. Or we're noticing, hey, all the defrosts are suddenly running way longer than they used to, and some of them aren't even getting up to temperature. That's the kind of thing where then you can start to make these inferences. Even if you don't have that building temperature or the building pressure sensor, in some cases, even if you don't have the relative humidity and temperature of the sales floor, you can still make those kind of guesses. They're educated guesses, but they can still be really powerful, especially if you have a junior tech going into the store trying to figure this out. They're scratching their head thinking, I have to fix 10 case alarms today. Like, how the heck am I going to do that? If you can give them this idea, it might be this one magic bullet to solve everything at once.
And usually the consensus is for any technician, oh, it's maintain temp, it's fine, walk away. You know what I mean? Yeah. Like, because I've had calls, where they'll say something like you had just said, similar, where they're, hey, this EPR has been at 100%. Well, it's maintaining temperature. What do I care? You know what I mean? Well, no, there's a reason for it. There's a reason why it's been open for so long. You know what I mean?
And you're going to be back at that case in the next 2 weeks.
Correct.
Yeah. I mean, this is, I'd love to actually hear you guys' thoughts on this, but, our customers complain to us about technicians all the time. It's like one of their favorite pastimes is complain about their technicians. And
Kevin, I'm muting you right now, by the way.
I mean, what we've learned is like, look, these technicians are not evil. They're not trying to do things badly. That's not at all what they're trying to do. They're trying to do their very best. At the end of the day, technicians are being forced by the industry to get case temperatures back down to set point and get out of the store as fast as they possibly can. Like everyone in the whole industry is forcing techs to do those two things and nothing else. And so, what techs don't care about is, is this problem going to come back later? Is this going to be really terrible for the energy bill of the store? Or, is this going to cause a whole host of problems next week? It's more about like, hey, how do I get this case cold? How do I get out of here onto the next call? Because that's what I'm being paid to do. And that's what I'm being measured on. I'd love to hear your reactions to that. Is that what you
I mean, unfortunately, it's 100% a customer problem. They drove this whole industry to that.
Yep.
It's all bottom dollar, as cheap as they can get it. I mean,
not to exceed.
Yeah, let's be honest here. Grocery stores are cheap. I mean, we all know it. I mean, it is what it is. I mean, they drove it to this. I mean, they squeeze some of these contractors are so squeezed for this. I mean, there's no money for training. There's no money for that. And then unfortunately with all this, GPS apps and everything else, they're forcing all these guys out of here.
Yep.
I mean, we've had more guys leave in the last year than the last 5 years to go do.
That's going in the wrong direction. We need more people right now.
Yeah. And unfortunately, until that whole mindset changes, it's going to be like that. I mean, you get these younger guys in there. I mean, it's sink or swim.
Yeah, exactly. And it's so high pressure that, and the money is getting lower. So, I mean, these are all things we're hearing. I didn't mean to hit a nerve there, but this is the kind of stuff we're hearing all the time. And it's like, what we view ourselves as like, our goal is not to ever replace technicians. Our goal is basically to help customers understand that what they're forcing technicians to do is not in their best interest. And also turning those junior technicians and making them as effective as senior technicians early on. So the whole idea being like, look, if we can basically send these indications to the customer, these anomalies that say, hey, there's this problem that's about to happen, and here's what the root cause is, and this is exactly how you fix it. And then, a junior tech can come on site and effectively solve the root cause the very first time. That's good for everyone. And then the customer starts to realize, hey, solving the root cause of problems is pretty great. Maybe I ought to try to do that more often rather than making techs, put Band-Aids on everything and get out as fast as they possibly can. That's how we think we can change that. We can at least help to try to start changing that paradigm a little bit.
That'd be great. I mean, that's honestly what needs to happen, because I mean, it's pushed more towards the Band-Aids more and more. Not to change the subject, but let's. I want to get into the actual where you said earlier you guys are reading and writing. I think I heard you say you could write to the actual controllers also.
Yeah. So let me actually talk about the other app. So we have two kind of our premium apps. The Virtual Technician, that's the predictive maintenance one we already talked about. The other one is Virtual Battery, and that one is more on the energy side. So essentially what we're doing with Virtual Battery. Have you guys ever gone into a grocery store, or I guess any other commercial building, and seen a huge battery pack in that store or in that building? Like from Tesla or from, a bunch of other companies like that.
Tons of solar panels, never a battery.
Lots of solar panels, no battery.
Okay. Well, I think you're going to start seeing those more and more. And basically, we're ending up in this situation where, electricity travels at the speed of light, right? And there's no energy storage or a tiny, tiny amount on the grid. And so supply has to equal demand on the whole grid every single day, every millisecond. Or you have blackouts. And so that's worked for a really long time, just because there's so many people using and producing energy and all this stuff. But now over the last 20 years, we started putting a huge amount of solar, which is intermittent wind, intermittent electric car charging on the grid. And so now the grid is destabilizing. And so utilities are scrambling, and they're putting in place these massive price incentives and these huge rewards and payments and all these other things to get more energy storage onto the grid. And so that's why companies like Tesla now are deploying huge battery packs in the back rooms of buildings, in substations, stuff like that. I'm sure you guys have seen some of these articles about Tesla putting these, just enormous battery systems in Australia and stuff like that. It's all the same thing. It's happening everywhere. Bottom line is basically what we can do is, if you think about the energy bill at a grocery store, first of all, the refrigeration is consuming 55-60% of all the energy in the whole store.
Absolutely.
And then you look at that energy bill from the local utility company, and the quantity of energy, the kilowatt hours of energy, is only driving 30 to 40% of the dollars on that bill. The other 60 to 70% of the dollars on that bill are driven by demand charges. So, what's the peak energy consumption in one 15-minute interval in the whole month? That's really bad news for grocery. Because if you're flexible, that's great, because you can be flexible and you can move, or you can shift your energy consumption and all the stuff. You can lower that number a lot. Grocery stores are not flexible. They're some of the least flexible folks in the whole grid. And that's because this refrigeration just chugs along 24/7, at a pretty constant rate. Goes up a little bit during the day, down at night. But, it's like a nuclear power plant. It's not like a little gas peaker plant that can turn on and off all the time. Long story short, what we can do is we can essentially make a Tesla battery pack appear out of thin air using software in that grocery store. So we think about a battery, it charges and discharges. It consumes more energy when it's charging, and then it kind of offsets how much. Basically, the building consumes less energy if that battery inside the building is discharging. And so you can use that battery in the building to change how the whole building is consuming energy over time, and kind of change the shape of that load profile. And so what we're doing with the Virtual Battery app is we turn the low temperature refrigeration into that battery using software. The whole idea here is that, you go into the core idea is that as long as something's frozen, it doesn't really matter how cold it is. So you go into a Whole Foods and you pick up a tub of Ben & Jerry's ice cream. It's going to be -5 degrees Fahrenheit. You go into Costco, you buy that same exact tub of Ben & Jerry's ice cream, the supersized version, and it's likely more like -20 degrees Fahrenheit. And so most folks out there have no idea. They don't care. It doesn't change their quality of life at all. And so that's the hidden degree of flexibility that we're unlocking here. The whole idea is we're basically using the ice cream, the frozen chicken, the frozen peas as a thermal battery. And so, just like a battery charges and discharges, we'll charge and discharge our virtual battery we'll charge it by driving the temperature of some of those low temp goods down a little bit, a couple degrees. So we'll take the ice cream from,
during the night,
during the night or early hours of the morning. Yeah.
when the peak's not, or I'm sorry, when the demand's not at peak, right?
Exactly.
Okay.
Yeah.
Sorry to interrupt. I'm sorry.
No, totally. Yeah. And so we'll do that by basically, commanding on an extra compressor or two, or, closing an unloader or turning up a VFD on the compressor rack. And then we'll open all the EPRs or the solenoids, for example, so that more cooling is flowing to those cases. We're driving it below the set point. So those are some of the overrides that you were asking about earlier, Kevin.
Now, are you doing overrides, or are you actually writing two set points saying, okay, this is A05, we're going to change the set point from -5, we're going to change it to -10? Or is it just overriding EPRs in the background?
It depends on which controller we're using, actually. So we've built different integrations for different controller types. And for certain controllers, there is considerations around, how many writes can you send to a specific set point without burning out the board. So we'll use a different technique for those. For other types of control systems, there are considerations around, hey, are we communicating on the device level or on the control system IP level? So I don't even know all the answers to that question, to be totally honest. You'd have to ask one of my colleagues. But yeah, it's a combination of those two things. In some cases, we're at the device level. At other cases, we're at the set point level.
I mean, it could be as simple as, having dual set points on the rack, right? Where you have alternate set points, and then, basically either enabling or disabling a float where you have the suction pressure buried, right?
Yeah.
And basically disable the float when you're trying to, charge that thermal battery. I mean, I'm not trying to simplify or downplay anything you're doing, but like almost what they used to do with in more expensive areas, what they used to do back in the 70s. And back in the 60s with water, you'd have this 150, 200 gallon water tank that had these massive kilowatt, heaters, and they'd heat the crap out of it at night. And then basically then during the day, they turned off the heaters and, relied on the supply that was already stored. So you're doing the same thing, but with your software, correct?
That's honestly, that's a really, really good comparison. Yeah. So the one thing that we haven't talked about yet is the other end of the equation. So, first you charge the battery, then you get to discharge it. The way that we discharge it, that's where it gets more interesting and more complicated. And that's where the software really shines. So basically during load shed periods, we have to look at, we're trying to reduce the building's peak, right? So we have to, first of all, we're going to predict when is that building going to peak? Maybe it's, 3:15 this afternoon. And so we have to be prepared for that. So how much do we want to pre-cool in advance of that? How much charge we want in our virtual battery? And then when we get to that period in the afternoon, then we're going into a reactive mode. We're kind of watching and waiting and seeing what's happening in the building. And we're looking at the building's electricity meter in real time. And the software is basically deciding, all right, I want to throttle down the building's energy a little bit right now. And so maybe I'll shut off a compressor. What's really important here is that suddenly you don't have enough cooling for the low temperature. For all the cases are asking for more cooling than the rack is providing. And so what we have to do in that case is that's the point where in load shed mode, we're essentially coordinating like an orchestra, all the individual EPRs for every single display case group. And we're duty cycling them, or we're using the variable aperture electronic EPRs basically to make sure that we're allocating cooling in a really, really intelligent way, so that all those display cases are rising back up to the initial set point in a really coordinated way. So obviously, a coffin's going to warm up, or an open door region is going to warm up way, way faster than a really well sealed, closed door region, for example. And so we're going to be sending more cooling to certain types of cases, and we're changing the positions of those valves every 15 seconds throughout that entire whatever period it might be, 15, 30, 45 minute period, 2 hours, even 4 hours sometimes.
I mean, that's a
whole
lot
idea.
Background. I mean, this seems like a lot. I mean, have you guys had issues with controllers not being able to handle it? I mean, some of these controllers are kind of almost archaic.
Yeah. I mean, at the beginning, there's a bunch of engineers on our team. And so the engineers were saying, we're going to get this really, really precise. We're going to make these changes every 15 seconds. I think now we're doing the calculations every 15 seconds, but we're actually only sending commands or overrides much less frequently than that. So, maybe we'll send a command to 10% of the valves every 2 minutes or something like that. I don't know the exact numbers, but yeah, you're right. We never want to overwhelm the network or the controller, because that's not a good outcome for anyone.
Yeah, I mean, this seems like super interesting. I would like to know more about it on the actual control side, how it's doing the set points, if it's actually writing to them or if it's overriding them. I mean, because that for as like a technician walking into that could be very confusing while that's
Totally.
going on. I mean,
Why the hell is everything blue? What the hell? Everything's override?
or like, everything's changing rapidly. I mean, that right there. I mean, there seems. I mean, this whole thing seems great, but at the same time, it seems like it needs a ton of training on the technician side to actually understand what's going on and not have this freak out moment.
Totally. Yeah. I mean, we basically, so the stakeholder training is so important for us. And we'll definitely, every time we deploy at a new store, we train the store folks. We train the service providers who are servicing that particular store. And it's really easy. It's just, hey, AXIOM is here. This is the kind of behavior you might see. Don't be surprised by it. If you have any questions, give us a call. And by the way, there's a big, huge red button. Hit that red button if you ever want to stop everything and go back to normal operation.
So yeah, that was the next thing I was going to bring up. So what happens if you guys lose communication, like Ethernet communication to the store or whatnot, while this is going on? Does it stop? Does it revert back to whatever the controller was doing? Does it unwrite all those settings?
Yeah, it goes right back to as if AXIOM was never there. It goes right back to basically like the E2 will just go back to what it was doing before. So the E2 will wake up from a sleep basically and say, huh, that's weird. All the cases are a little cooler than I remember them, than they should be. I guess I'll throttle down the compressors a little bit until they come back and I'll turn them all back on. So yeah, that's the whole idea being that, the worst case scenario for us is that we lose communication. And, if you think about what we're doing, the temperature is supposed to be at a certain set point. During pre-cool, we lower it. And then during load shed, we let it get back up to the original set point. So even if we lose communication at any point during that pre-cool or load shed, it's still the whole store is at a lower temperature than its initial set point. So there's quite a bit of buffer.
Now, with that whole thing going on at the same time, wouldn't that, how does that affect your guys' predictive maintenance? Because now with that load shedding like that, I mean, you're obviously going to have weird case swings. Stuff's going to kind of be, all over the place, as you're load shedding. So how does your guys' predictive maintenance, look at that and ignore it? Or does it, only look at it when it's not running that way?
Yeah, it's a great question. I mean, think about when you're going into a grocery store and you're like, hey, this is really weird. I don't fully understand what's going on with this problem that I'm seeing. A lot of times, tell me if I'm wrong here, you're going to go in and you're going to make some tweaks and see how the system reacts, right? So, I mean, if you think about what we're doing with virtual battery, we're making a bunch of tweaks at the store. And a lot of times that actually helps to kind of unearth or, make problems visible that we otherwise couldn't really see. So it actually helps us with identifying problems in a lot of cases. Obviously, the algorithm, the virtual technician digital twin, or the digital twin model knows that the virtual battery app is operating. And so the virtual technician app is not going to, get confused by that because, it knows.
Now, are you concerned with any kind of shrink? I mean, because you're basically, utilizing the product to keep a little bit of temperature, and then I'm assuming you're raising up the temperature a little bit to release some of the on-peak demand. Is that correct?
We never go above the initial set point. So
Okay.
If the store is set at -5, we might drive it down to -10, but then we'll let it slowly get back up to -5.
Okay, so you never go above. So the product's never in jeopardy then.
That's right. Yeah.
Okay.
I mean, can you imagine trying to sell to a grocery store? Hey, I'm gonna, warm up all your product on the hottest day of the year.
Well, yeah,
that would be a tough sell.
Yeah, I would I didn't know if you would I mean, they have some, in some parts in the program where they do call it load shedding, where they'll raise the product, not the product temperature, but basically the discharge air. Hey, we don't really need that case all the way down to this. It's still going to maintain temperature. You know what I mean? And it was just
yeah. I mean, on the beverage, I could see that on a beverage case making sense, but on medium temperature, like milk, good luck, and definitely not on low temperature. I mean, I always find that so funny. You look in these controllers, and they're like, hey, we offer demand response. And so then you really start to dig into it. And what does demand response mean? It means that on the hottest day of the year, you're going to allow your suction pressure to go way up. That doesn't sound like a very good outcome to me. That sounds like the worst outcome. So we're trying to change that paradigm with the pre-cooling, with the intelligence. It's not just a simple time clock. We're never going above the initial set point.
What were you saying, Kev? I'm sorry.
I just totally forgot my train of thought.
Oh, sorry. I was interrupting you.
It's all good.
You got me going there.
So with this whole software, so you guys have this and you have the mobile tech and all it, or the I'm sorry, I didn't mean to butcher your the digital tech.
Oh, virtual technician.
Yeah.
Yeah.
So
yeah.
now is this something that, like, okay, say a facility has like, we have a lot of facilities that we can't dial into, like they're, that a lot of people get very stingy with the VPNs and stuff. They don't, want certain people on there. With that, are you guys able to have like a separate portal for like technicians to go into to look at data? So say if I wanted to go pull up the store down the road from my house and look at the data on there, I could pull the data on this case. Is that something that, you guys can make separately available to techs where it's secure for that store's network and it's still available to us? Maybe we could override something or, force something on, or, like a dashboard or anything.
Yeah, or at least do some diagnosis with data remotely. Yeah, 100%. So, I mean, that's the other thing. Like, we hear these stories all the time of technicians feeling, or, I guess a lot of times it's kind of the management in these service companies who are saying, we're flying blind. We get some really cryptic phone call or email saying something's wrong. We have no idea what's going on, how urgent it is, what level of tech we have to send. And so we just have to send, the best tech we have available as fast as we possibly can. And a lot of times it's just not, you didn't need to, basically. Or you send a more junior tech and it's too complicated for them to figure out. And so then you can't really have a more senior person help them out remotely because there's just no data access. So yeah, long story short, there are definitely cases where customers will let us on the VPN and then we can do everything through that VPN, which is great. That's easy. We don't have to have any on-site hardware. In other cases, especially when we're doing free trials sometimes, we will actually install a little on-site cellular gateway. And so, we'll bolt that on the wall. It takes a couple hours and plug it into the controller or plug it into the device network. And basically that becomes our data backhaul. That's how we're moving data in and out of the store. It's on a cell card, on a SIM card. And so with that, basically that's how we're piping all the data into the cloud. And there's various access levels for the cloud portal. You can see every single data stream in the entire controller in our cloud for all of history, however long it's been connected. It's not 2 weeks or 3 weeks like an E2. It's that particular thing really boggles my mind that they're only storing a couple weeks of data. And yes, we can give the techs access to that depending on if the customer allows it.
Are you limited on like if the controller is only logging once every 5 minutes, do you have the availability to not basically redo the logging? Because a lot of these controllers have limited space. I mean, that's the whole purpose, right? Basically they'll log a controller for temps once every 5 or 10 minutes, right? But then like a liquid level, they might do once every half an hour. It's just so they can keep a graph of the year, so they can see if there's any downtrends. Now, are you limited on what you can log, or can you change what goes up to the cloud based off of what you want?
Yeah, we can change what goes into the cloud based on what we want, basically. So, for example, when we're working on microthermo stores, we can actually, this is applicable to Emerson stores as well. Yeah, basically, as frequently as that sensor can report, the limitation is the sensor. The limitation is no longer that controller, basically, is the short answer. So if we can get data out of a sensor every 10 seconds, that's the limitation. We can get data to the cloud every 10 seconds.
So example, Emerson monitoring, let's just say their controller is already set up for, the 5-minute increment, the 10-minute increment. You have the availability to still pull that data back without having to change any of the logs, and then, updating that logs to your cloud every, 5 seconds or 10 seconds or whatever it may be, correct?
I am 90% sure of that. I don't want to say that 100%, but yes, I'm very, very sure of it, but I can't say with 100% certainty right now.
The only reason why I'm asking, because like some of these new case controllers, right? There's hundreds of bits of data, right? You have superheat, defrost termination, valve position, superheat, like just the list goes on. The amount of pulsing that the anti-sweats do. So there's massive amounts of data, and unfortunately, sometimes a lot of these facilities, they'll have it speak at 9600 baud, right, instead of 15.2. You know what I mean? And which is dumb because it's transmitting that much data where basically you'll lose some of that going back and forth. So I was just interested if you have the availability to pull as much data as humanly possible, because it does make a lot of difference when you're trying to diagnose something. You know what I mean? When you have a lot more data to deal with, but
more granular and longer periods of time.
It would also help if half these controllers didn't have the worst processors known to man in them.
Hey, it's better than what your last computer was.
It's probably true.
That computer,
well, at least it's not Control, right?
Don't hate on Comtrol. I like Comtrol.
Today's episode is sponsored by Westermeyer Industries, the leaders in oil management and pressure vessels for the commercial refrigeration industry. Whether you're involved with designing a system or tasked with servicing one, Westermeyer Industries has been helping meet the needs of customers like you for the past 20 years. They offer a broad catalog of stock system components with an in-house team of engineers to assist with custom solutions as well. From oil separators and heat exchangers to system monitoring devices, Westermeyer Industries are a total system specialist with industry expertise, engineering know-how, and the manufacturing muscle to help you tackle problems and deliver solutions.
Control.
That's terrible.
The second time I hit a nerve tonight.
The screen half of them out there, the screens are like half dead dim. You're like looking at them with the eyes kind of closed.
But hold on, compare it. All right, so they've lasted 20 years. That's all I'm going to say, if not more.
That's fair. If they're still out there, then they have gone above and beyond their service careers.
If the computer that's in the room that connects to him is a Commodore, like I didn't even know what that was.
Yeah, I don't think I could point out a Commodore from a lineup.
The only reason I know is because there's one sitting in a corner of a big chain up here in every single rack room they have. And
I guess you never used old school Metasys.
I did not. I think I'm lucky.
Yeah. So, what controllers can you guys all integrate to? Like, what who do you work with? Who can you work with?
Right now, we work with 3 major controllers: Emerson, Parker Microthermo, and then Logic. And Logic is actually, are you guys familiar with Logic?
Automated Logic?
Logic, these guys, I think there's a bunch of companies with similar names, but this particular company is Logic. I think they're based out of Georgia. They do a lot of the refrigerated warehouses in North America. So, we're also working with refrigerated warehouses. Like
more like ammonia stuff? Or is it?
Currently, our refrigerated warehouses are HFC, so they're big, huge screw HFC compressors. We haven't done an ammonia one yet, but it is going to be some modifications to the digital twin model to make that possible, and to make it operate at a really high level. But it's the same basic concept.
I do have to say you have to make a phone call to RDM. Their processor, the amount of data that they can hold, just even in their controller, is just utterly amazing.
I'm so glad that RDM has entered the market. They're making great progress with HEB. I think there's at least one other big chain they're working with, right?
Yeah. I was having a conversation today, and because they're a European company, basically, I was actually on a webinar today about CO2, and it was basically breaking down like what regions, have basically the most, transcritical booster systems. And there's like United States had 500 of them. Canada had X amount. And then Europe had 23,000. I'm like,
oh. Wow. And all 500 in the US are Aldi, which is another European company, right? So
I have probably started up at least 15 or 20 Aldi CO2 racks in the last year and a half.
Wow. Yeah, those guys they're leading this whole market. It's unbelievable.
We actually have, I think we're over at least 100 plus in Chicago.
Really?
Yeah, I mean, they've gone full bore between Aldi, Kroger, and Costco has gone like nuts in Chicago with CO2. I mean, there's more CO2 racks going in than there is DX racks.
Amazing. Wow. Finally, the tide is turning.
Yeah, I mean, I've done more transcritical work in the last 5 years than I have DX work here lately.
See, HEB is getting real big into Cascade, but I mean, until it actually starts cooling down here in Texas, I can count on one hand how many transcritical racks are here between here and Oklahoma.
Yeah, that's not the greatest location for those, but
Correct.
yeah, I'm so glad RDM entered the market. I mean, those guys are bringing, like open source data sharing, the ability to communicate over IP, just like, wow,
That's
a whole new world.
a lot easier for you guys to do what you're doing if you're communicating over IP, I would imagine.
Oh my gosh, yeah, it makes our lives so much easier. It's like logging into the internet versus trying to, hack I don't even know. Yeah, totally different ballgame.
Doing these controllers, you guys are basically, jailbreaking them and getting into them that way.
So
that's right.
That's kind of how we started, to be totally transparent. But then then we started working with the control companies, and they've been really great partners to us. And they're helping us out, and we're basically we're accessing those controllers in kind of we're going through the front door at this point. We're not going through any back doors. So I think that the industry is ready. Everyone is looking for these opportunities, for these ways to use data. I think even the people who are really happy with the way they've done business for decades are starting to see that it might not necessarily be that way 10 years from now, and they're kind of ready to crack open the door a little bit and think about, hey, how can we start sharing data? How can we make data accessible on the internet? How can we use data to transform how these systems are running and just have better outcomes for our customers? How can we use data to solve this huge shortage of great maintenance technicians, stuff like that?
Yeah, I mean, I like the idea of the analytics side of it. I mean, just having it available and having long-term trends. I mean, that's a huge deal, is like trying to keep those trends, especially with an E2. I mean, you're limited on those trends. It's not like microthermal where you can keep in the data logger for years. We're limited on those trends. We don't know what it was doing last month, but I mean, with what you guys have, I mean, now we have that data. I mean, I think that's great.
Totally, yeah. I mean, if that's the one thing that we can do for this industry, just make data accessible on the internet, even that's a win, honestly. Obviously, we're trying to do a lot more than that, and so far it's going pretty well. Right now we're in 5 big grocery chains in North America, so I mean, we're growing really, really fast. Hopefully, we'll have some Chicago projects for you to work on soon, Kevin.
That'd be nice. Are you guys moving into the commissioning side of it too? Like, actually like making baselines for the rack, or are you just, this is the recommendations we recommend, or are you guys going in and actually, hiring a company or going in yourselves and recommissioning the rack, set the baseline, and then going from there? I mean, I feel like that's a huge, thing with these trends.
Yeah, no, I hear you. I mean, I think what you're talking about is this model where you hire a commissioning company to come in and tune up your store, and they spend a week and it costs $15,000-$20,000, right? 3 weeks. Wow.
Well, I mean, a lot of times, companies they'll say where set points are going to be the most optimal, but like once they do that, I don't know how many times this happens where a commissioning company will come in, they'll set up the controllers for floating, and they'll set it up to save the most money, floating head, floating suction, and then the technician's like, case ain't maintaining temperature, float's getting it gets turned off. You know what I mean? And that
failure with this every single time is. Well, I'm serious. I spent a lot of my time doing commissioning, and I trained an entire service department in my last shop of people that did it the way I did it. And the biggest hurdle with all this, once you start, especially some of these older guys, you start pushing into this, floating head, floating suction, the biggest failure of all of this, you could do all the analytics in the world. If you do not train that technician on what you just did, it is going to be the problem every time, and it is going to be a failure.
Mm-hmm. Yeah, and yeah, every time something little goes wrong in the store, the commissioning gets blamed.
Or controls.
Yeah, 100% commissioning gets blamed. But yeah, I mean, you could have all the algorithms in the world, but I mean, until you train that boot on the ground, he's going to be in the manager's ear saying that this is the problem. It was working before, even though that this has always been here and it's been hidden, but it was working before.
Yeah, so I've heard a tech say I got hit by commissioning, like it's a bad thing.
Well, the customer's trying to save money, right? I mean, unfortunately, they have all these KPIs that basically, are showing, a lot of usage, a lot of, technicians being on site, and a lot of problems get hidden. And, you laughed when I said the word offset, because I know you guys, you've seen it a bunch, but we had a particular store that we took over, and they would, wouldn't have problems, whenever the float wasn't working. And then as soon as the float would work, basically the case would never maintain temp. Well, line set was supposed to be 1'1", and it was 7/8. So it caused a restriction, caused a higher pressure drop than anticipated, then potentially would never, always run a little bit higher temp, causing shrink. So there's oh, the float's junk, doesn't work, throw it the hell out, and then basically customers ended up not saving money. So that's why I said 3, because basically the company comes in, commissions it, does whatever they need to do. But typically what needs to happen afterwards is they write down a deficiency list. Listen, we implemented floating head, we implemented floating suction, but now these cases aren't maintaining temperature. There is a problem. But a lot of times, like you had stated before, sometimes hey, just send the kid, will be fine, and then basically I'm serious. I mean, it happens all the time. And then basically, it happened because the commissioning company, we got to change it back to the way it was. Those set points aren't going to work.
Yeah, at least the cases were cold.
Yeah, they're not working now.
Yeah, and it's not their fault either. It's not the tech's fault. I mean, basically, so you guys are just hitting the nail on the head. My gosh, it's for example, we went to a customer who fancied themselves to be basically the most energy efficient grocery store in the world. Or chain in the world. And so then we went, installed a bunch of their stores. In 70% of their stores, the floating suction was on, but it wasn't actually providing any value. And for so many different reasons too. There's all kinds of different reasons that the floating suction was all junked up. And so that's the kind of thing where it's you can spend $15,000 and have someone come work on it for 1 or 3 weeks and walk away and then come back 5 to 7 years later, but you're only going to get 6 weeks of benefit out of that, because it's all going to get reversed, or it's going to, if somebody puts a new case in the lineup, or whatever else, you do a 448 change out, 449, something happens, and your entire commissioning goes out the window. So this is another example of maybe another one of the most basic examples of why having software watch this stuff and monitor it over time makes sense. You just can't possibly pay humans to do that. It doesn't make any sense for anyone.
I agree. I mean, after doing what you guys are doing after commissioning, I think is the key. Once you set that baseline and have it, watched afterwards, that is the key. I mean, get it running like a Cadillac, and then, then watch it over time to make sure it runs, keeps running the same way, and make sure, somebody didn't put their paws in there and start messing with stuff. And,
I think that's the best case scenario. But if you don't have the 15 or 20 grand to spend on the commissioning, it's still better to basically start using software to get ahead of problems and at least identify the biggest synergy opportunities, even if you can't, pay that guy to be there for 1 to 3 weeks.
Well, then at that point, that's when you derive your own KPIs and be like, hey, this is the energy consumption you could be saving. This is, what I mean? So,
yeah,
and that's the only, unfortunately, a lot of these customers, that's the only language they talk. I can save you money. Do it. You know what I mean? If it's going to cost, do it.
Yeah. I mean, the conversation that we have with customers a lot is, hey, give me $1 today, and I'm going to give you $10 over the course of this next 12 months. And a lot of folks say, hey, can I have it for 85 cents? It's come on, guys. Let's get this project done. Let's save you a bunch of money. Why are we haggling over price here?
It's called stepping over to $1, save a dime.
Yes. Yeah, exactly. Yeah. So I think that's really a big problem in the space. And I think a lot of it is what we were talking about earlier with, T&M not to exceed.
So I'm going to ask you this question, and I understand if you can't answer. Anything, because everything you're talking about is amazing. But like, is there anything else that you guys are moving toward? Hold on, airplane. I'm like right next to the Houston airport, so it's like the airplanes literally go right over. Is there any new innovations that you guys are working on that you can speak of at this point?
Yeah, totally. So I mean, one of the big things that we're doing right now, this is a feature that it's still in beta mode. It's still in beta, which means that we can't say that this works 100% perfectly all the time. But basically, the idea here is refrigerant charge management. And so with refrigerant, if the whole idea here is right now there's no gas needle on the side of a refrigeration system, right? Nobody knows how much refrigerant's inside of it at any given time. You just kind of guess. And then if there's a leak, it runs out. And then when it's zero, then you add more, or when it's getting really, really low. And so, the whole idea here is that if we're using the digital twin model and we're able to model, how much is in the receiver and how much is in the condenser, using all kinds of different data sources, enthalpy in, enthalpy out, drop leg, superheat, stuff like that, and then looking at receiver levels, a lot of different data streams. And then we're normalizing for is the condenser split on, is the heat reclaim on, things like that. Then we can start to really precisely approximate how many pounds of refrigerant is in this grocery store or is in this particular system. And from there, once we have that approximation, we're running that calculation all the time, then we can start looking at changes in that level over time. So basically, you can answer a couple of questions. One is, does the system have a leak? And another is, is the system over or undercharged? And so those are the types of things that we're looking to accomplish with data. We're having really kind of promising early results on this. We're not fully ready to, say, hey, this is fully baked feature yet, though. So we're still in the process and iteration phase on that. I don't know, have you guys, seen or heard similar things like that before? We've definitely heard of other folks working on similar problems in the past, but our perspective, no one really has cracked the nut yet.
What, as far as refrigerant management?
Yeah, refrigerant management is basically like finding leaks before you run out of gas, stuff like that.
Well, it goes back to stepping over $1 save a dime. They could do basic leak check PMs, and there are some customers that are very, very conscientious, like as far as like they will write those work orders. Hey, listen, you've added this much gas, it's time to do a full store leak check. And then, yep. And some of them actually doing KPIs to grade the equipment where, if they have X amount of loss, they're going to be like, let's get rid of that, those lineup of cases. Seems like we've had a large, instances of issues with that. Or, we've had issues with, that rack's 20 years old. It might be time for a remodel. You know what I mean? Because at this point, a lot of the customers have been hiring people that have worked for the EPA, so they don't get those fines. I mean, because not that some of these fines will bankrupt some of these bigger companies, but independents don't stand a damn chance.
Mm-hmm. No, you're absolutely right. There's some really cool stuff coming down the pipe, like the infrared sniffers. I forget which company's making them, but you get the back rack multi-channel sniffers. That's one option. I think that's been around for quite a while. And then you have these new infrared ones, but even then, people are not putting those all throughout the sales floor. Maybe you have one and one return somewhere in the sales floor or in the HVAC. But it's going to be really tough to really pinpoint where the problem is, or if there is a problem on the sales floor a lot of times.
Well, as you probably see, with all these remodels and stuff, they're limiting the amount of piping. The name of the game at this point is to make sure that you're getting a hell of a tax deduction, right? So, the less refrigerant, you get the green chill.
Green chill, yeah.
Yeah. Basically the refrigerant charge is under X amount. So, that, like Walmart's a prime example, their rack houses are right on top of the damn cases. And that's to limit the amount of, refrigerant charge in the system. Right. Mm-hmm. So, a lot of these companies are doing that.
There's also more reasons than that. It's because they get taxed if they put a rack house on the outside of the building. Seriously.
Sound. Probably sound.
No, they get taxed because it's an outbuilding.
Oh, okay. Property
It's-
taxes or something like that.
Yes. So it has nothing to do actually with them putting for the charge or anything else. This is what I was told by from a couple Walmart engineers. It all has to do with them getting taxed.
Well, there's also that other benefit.
Yeah, I mean, it ends up being another benefit, but it actually costs them more money to put it on the roof.
Yeah, more bracing and stuff in order for the make sure the building can take it, right?
And it's more expensive to pipe a rack on the roof than it is on the side of the building.
Wow.
So
yeah, I mean, we think there's a huge opportunity here. Again, going back to the climate change thing. I hope I don't alienate listeners here, but I mean, leaking refrigerant is terrible. It's so bad for climate change. And so if we can reduce a little bit of leakage, I think the average leak rate right now in the US is 25% per year. So that means every 4 years, a store dumps its entire charge on average.
That sounds about right.
It's horrendous. So if we can, help to identify those types of leak events sooner, especially the small ones that are going under the radar today, the small and medium leaks, that they just leak and leak and leak until it's too late, until you have case temperature problems. If we can alleviate or identify those a lot sooner, a day or 2 or 3 days in, rather than 6 weeks later when you're out of gas, that has a massive climate impact and also, a really good dollar impact too.
So I have to ask, because now you got me curious. So I understand that you push this because of climate change. You stated that. How about what was your background in that you leaned into this?
Into like grocery refrigeration specifically?
Yeah.
So I was at school, studying energy engineering essentially, and then I went to my first job out of school was working at a energy services company, and so we were basically helping big multi-building, people who own big portfolios of buildings, reduce their energy and their water and their operations spend, and then we were financing out of the savings. So the whole idea was, hey, we'll give you a bunch of free equipment, and we'll get it all tuned up and installed for you for free. And then we're going to generate a bunch of savings for you, and you just pay us out of those savings every time. So no CapEx, all OpEx. And so when I was there, one of our biggest customers was a major national grocery chain. And so that's how I got exposed to this. And so the first thing that I found out was, or when I started learning about the industry, is like, look, there's 38,000 grocery stores in the US. There's another 12,000 in Canada, whatever, 5 or 10,000 in Mexico. I'm forgetting right now. And every single one of those has massive heat pumps in the back of it. Every refrigeration system is a huge heat pump. And so I view that as just this enormous energy opportunity. If we could transform those heat pumps into something that's flexible and then use them really intelligently, think what that could do for the grid. Think how much more intermittent solar, more intermittent wind, more intermittent electric car charging we could plug in if the grid was more flexible, more intelligent, more resilient. Because all those heat pumps suddenly are responsive to the needs of the grid rather than just chugging along all the time. Also, the other thing that really actually gave me a real kick in the pants was that customer I was talking about, that major national grocery chain, they sat us down on the first day of the project and they said, here's our whole energy spend. Here's a pie chart. Refrigeration's 60% of it. And don't touch that part of it. Nothing you can do. It is what it is. Focus on the other 40%. That really made my blood boil. That was I think that was the original kick in the pants that really made me realize there's such a huge opportunity here from an energy standpoint, and also just to help make the grid more stable too. Then we dive deeper and deeper. I got to know a lot of the people and understand their key concerns, figured out the maintenance elements, figured out the refrigerant leak elements. So that's a lot of my personal journey. How about you guys? How'd you guys get into this space? It's not the sexiest industry to be in after all.
Go ahead, Kevin. You go first.
So basically my entire family does this. Like, I am third generation. So, I mean, every part of my family is somehow involved in this trade, even including my wife. So,
wow.
Yeah.
That's commitment.
So, they don't all do the grocery store stuff. Only me and my brother do. but every part of my family is somehow involved in this. So I don't know. I got suckered into it, and then I tend to like it, and it's good most days, and then there's obviously bad days, but I enjoy it. So I enjoy the side of what I do now.
Nice. That's pretty darn cool. Is most of your family in the Chicago area?
Yeah, so they're all in the Chicago area. Like some of them own companies, some of them work for different companies, but yeah, my entire family's done this. I mean, I've been doing this since I was like 12.
Wow, it's a pretty good summer job.
Yeah. So
better than me. I was mowing lawns.
How did I get in the industry? I originally went to school for electronical engineering. Got an associate's degree. I was homeless and ran out of money, so I got a job. And then basically after that, I got laid off. I was doing cell phone remanufacturing, then did graphic dimming panels for like stadiums so I could dim down the lights. Ended up getting a job because they were asking for some kind of scientific degree for water treatment for industrial cooling towers and boilers. And I was like, oh, this seems pretty cool. So I did it for a little bit, traveled all over, New York, New Jersey, Delaware. And I got really, really tired of just looking at water all day and started talking to a bunch of mechanical guys, because I didn't know how refrigeration worked. I had no freaking idea. And I was like, oh, I'm going to go to school. So first semester I went, and instructor pulled me aside. He's like, what the hell are you doing here? I'm like, real excited because I'm young. I'm like, I want to be a mechanic, and basically that turned into, you have a degree in electronical engineering. He's like, that's about 75 to 80% of what you do as far as PLCs, electrical. He's like, go get a damn job. So that's what I did. I got a job in residential, went to commercial, moved up to different forms of industrial air compressors, moved up to supermarket, and then went to industrial. So ammonia, Frickville or Sabro, that kind of stuff. And then basically got into EMS, and now I'm here in Texas, and now I'm manager of technical troubleshooting and training for CoolSys.
Wow, what a cool story!
So
it all started with water treatment. Okay, pretty circuitous route there.
Well, I mean, we dealt with a lot of cooling towers and boilers. You know what I mean? Because a lot of the places in the city, Kevin deals with what are cooling towers all the time, being in big high rises and buildings and stuff. Because I worked all over New York, New Jersey, Delaware, you know what I mean? Because I grew up in Pennsylvania. Which leads me actually to another question. I was going to ask you this earlier and I forgot.
Now the cooling towers followed you back with the adiabatics and everything, huh?
Yeah, right. What do you do to combat the voltage drops on these grids? Like, I mean, because basically, obviously, lower the voltage, higher the amperage, which means obviously, everything's working harder, more energy consumption. So, I mean, you guys would have to monitor that as well, right? And have the customer then try to talk to the grid, unless you're in Philly where the voltage goes down to 189.
Wow.
Chicago too. So
it's all the old grid.
Yeah. I mean, I never even really knew this was a problem until very recently when, one of our customers, basically, we saw some weird stuff happening in all the data. Suddenly everything went offline randomly, and it turned out that there was a big voltage drop and their main breaker had popped. And so had tripped. And so ultimately, not much you could do if there's a big physical breaker that's tripped on the front of the building. So in that kind of situation, what we can do is honestly just help diagnose, there's a voltage drop, and, tell folks you're going to go and flip the breaker. There's very little else we can do in that type of situation. Ideally, if there's a lot of energy storage on the grid, though, then when the grid is in trouble like that, when it's struggling, it's about to go under, that's when energy storage, in huge quantities can come online and start dumping energy back into the grid, or at least reducing demand on the grid. So, utilities have all kinds of programs in place, like frequency regulation, things like that, to help, fight voltage drop.
Yeah, you were talking about like using the product as basic big batteries. I mean, does anyone really ever entertain like actually putting big power packs in large facilities like this, supermarkets?
Yeah, so big battery packs like that, batteries are extremely expensive. And so they really only make sense in buildings that have short duration, high intensity spikes of consumption. So not grocery stores.
Not consistent.
Grocery stores have this kind of like smooth and sloping load profile. Whereas there's other buildings like commercial buildings of certain types where you're going along at 600 kW, and then suddenly you're at 850 for 20 minutes, and then you're back down to 600. A battery is amazing at that sort of thing. If you can just shave off that one little short peak, short duration, high intensity spikes. That's what batteries are good at. And so, there's been a lot of trial, maybe not a lot. There's been a few trials we've heard of people installing battery packs in buildings like, from, Green Charge Networks or from STEM or from Tesla. And they try it out and, it works, but the payback's like 10 years or something like that. It's just not worth it. Or it's very tough to justify on a broader basis. And so, our whole goal is basically provide the same exact value streams you get from that battery, but rather than paying $500,000 in CapEx, just do it, using software for a really small monthly subscription.
Well, man, let me tell you, I didn't realize like how much analytics was going into because I read a little bit about your company and was trying to so I didn't look like an idiot talking to you, and basically like, cause I mean, that's, I just wanted to make sure, I was trying to understand what y'all were doing, and I've learned a lot tonight, and I really appreciate you coming on. I really do.
Yeah. It was a good one tonight.
Actually,
really good conversation, guys. Yeah. You guys taught me a lot. I mean, you pushed me way beyond what I know about refrigeration, to be totally frank.
Well, I want to have another one, but next time what I want you to do is I want you to share some of the screens of the analytics that you do.
Oh, cool. I'd love to. Yeah.
Yeah. That would be great to be able to share some analytics, like to see what you guys are pulling and stuff like that.
Yeah, absolutely. In fact, maybe we should get someone smarter than me on the team to help with that if you guys are really interested.
Yeah,
who can really talk about this stuff.
I would love to get more into like how it's actually you guys are pulling the data and everything else, and some of that stuff. I mean, I would love to see some of the data also.
Yeah, you got it. Yeah, I'd love to come back on anytime.
All right. Well, listen, hey, I appreciate you coming on, guys. We're gonna call it a night. You guys have a good one, and we'll see you next week.
Hey, thanks for having me, guys. Really nice to connect.
Thanks, man.